Okay. So good evening, everyone. I welcome you all in the week 10 live session for the NPTEL course Non-Conventional Energy Resources. The course instructor is Professor Pratap Haridosa from IIT Madras, and I am his TA Amit Kumar Sharma. So today we will cover week 10 class content. As of now, we have covered up to week 9, and we have covered various aspects of renewable energy resources. And today we also cover another aspect of this domain. So let's start with the week 10 content. As you all know that every Monday we are having this live session from 6 to 8 p.m. So in this we discuss the previous week class content, and we also solve some sample problems so that you can 1 minute, so that these questions will be helpful in your current assignments. So okay, let's start with today's class. So first of all, in this week we will cover about the batteries, or we have covered about the batteries. Okay, so first of all, what is the batteries basic? So as we know that battery is a electrochemical device. Okay, as the name suggests, electrochemical, it means there are some electrical or some chemical reactions are there. Okay, some electrical connections, chemical reactions will be there. So it's an electrochemical device. First point. And second point, it is energy storage device. So basically, as we know that we can store energy in the battery, and we can use that energy for our applications. Like the basic example is our cell phones. So cell phones, we charge our cell phones battery, and we can use that cell phone for complete 1 day or maybe 2 days. And like similar like wristwatches, so they are having some batteries. Our calculators, TV remotes. Okay, so batteries are energy storage device. Okay, like electricity, as we know, electricity is continuously coming to our house. Okay, there is a continuous connection. If anything happens to the power supplier, or maybe the transformer from where your house is getting electricity, if any fault is there, then there is no electricity at your house. But it is not the case with the batteries. As long as the battery is, you can say, the charge or battery is having some chemicals that are responsible for the reactions, so battery will provide you the electricity. So in electrochemical, it is an electrochemical device. So there will be electrode phases. There's electrode, there are electrolyte, and there charge transfer. So electrode can be solid, okay, and there are different phases of electrodes. Okay, electrolyte also having some phases. Electrolytes can be also solid, polymer in liquid state, and there is charge transfer that is responsible for the electricity. The very basic question is, what is electricity? So electricity is the movement of electrons. Okay, so basically electricity is the movement of electrons. Okay. So electrons creates charge which we can harness to do work. So basically electrons create charge. Okay, like our mechanical work. So like similar to that, electrons create charge which we can harness to do work. Like your light bulb, your stereo, your phone, etc. Overall harnessing the movement of electrons in order to do work. So they are harnessing the movement of electrons and they are doing work. And what is the meaning of work here? Like from light bulb we are getting the light, from stereo we are getting the sound, and from phone we are getting our multimedia functions. We can talk and all, we can do all other things. Okay, so basically we can do our required work from that particular equipment. So they all operate using the same basic power source, the movement of electrons. The basic is the movement of electrons, that is electricity. So the three basic principles for this tutorial can be explained using electrons, or you can say they can create. So electrons can create voltage, current. So these are three major points in batteries: voltage, current, and resistance. So what is the voltage? Voltage is the difference in the charge between 2 points. Okay, if there are 2 points, so voltage is basically the difference of the charge between 2 points. So you can say the potential. So current is the rate at which charge is flowing. So basically current is the rate, like the 2 points A and B. So current will be the rate at which the charge is flowing from A to B. Okay. And the resistance is the material's tendency to resist the flow of charge. So resistance will be like if we are having some material, so that material is having some properties, so that will resist the flow of electrons. So basically it is resistance to the flow of electrons. Okay, so basically the resistance to the current, flow of current. So when we talk about these values, we are readily describing the movement of charge and thus the behavior of electrons. Okay, a circuit is closed loop that allows charge to move from one place to another. Components in the circuit allow us to control the charge and to use it to do work. So in a complete circuit, we can arrange the resistors and we can arrange the components to get the required current and to get our work done. Okay. So these are the basics of electricity, or you can say the battery. Let's move further. So yeah, here you can see a electrochemical device. So basically there is an anode, there is cathode, number 2, and in between the anode and cathode there is electrolyte. Okay, and there is external circuit which is connected with the anode and the cathode. Okay, so suppose any chemical reactions will happen at the anode and cathode. So the main point is that the electron that will be liberated from, like, due to the oxidation, and that will be consumed due to in the reduction, they will not pass through the electrolyte. Okay, so electron will not pass through the electrolyte. Okay, electron will only pass through the external circuit. So when the electron will pass through the external circuit, we can get the current. Okay, or we can get the charge. So this is a main point, that electron will not pass through the electrolyte. Okay, only ions will pass through the electrolyte to complete the reactions at both anode and cathode. Okay, so if you compare only the anode reactions, so that will be half cell reaction for anode. If you only see the cathode reaction, that will be half cell reaction for cathode, and the complete reaction will be full cell reaction. Or okay, so the main point here is that ions will pass through the electrolyte, but the electrons will pass only through the external circuit. So basically anode, where oxidation happen, and what is the meaning of oxidation? Oxidation is the loss of electrons. Okay, so whenever oxidation is happening, means there is loss of electrons. Okay, so that particular element is releasing the electrons, so that is oxidation, and basically, and it is called oxidation happens at anode. Cathode is reduction, where the gains of electron. So when element gains the electron, that will be reduction. Okay, so try to remember these points. These are very important and very basics for electrochemical studies. So oxidation is the loss of electrons, and reduction is gains of electrons. Okay, so in energy storage devices like batteries, fuel and oxidant are stored within the device. So both the fuel and oxidant, like fuel, you can say, like if we discuss about the fuel and oxidant, so you can see the example of our IC engines. Okay, in IC engines, what is the fuel? The fuel is your petrol and diesel. And what is oxidant? Oxidant is basically air. Okay, so when both the fuel and oxidant only combine, then only combustion can happen. Similarly, in the electrochemical devices, we need fuel and oxidant for the electrochemical reactions. Okay, but here there is no combustion. The electrochemical reactions are happening, and due to those electrochemical reactions we are getting the electricity. Okay, but if we talk about the, you can say, generator or like IC engine. Okay, so in that, what are we doing? That we are doing, like, we are converting the chemical energy of the fuel into mechanical energy through the combustion, and through the movement of the piston we are converting the chemical energy to the mechanical energy, and from that mechanical energy we are running a alternator, or you can say generator, or that is generating the electricity. So there are, you can say, first chemical energy, then mechanical energy, and then electrical energy. So you can say there are two process: chemical to mechanical and mechanical to electrical. So each process will have their equipments, okay, and setup. So they will have their efficiencies. So in, if we are going through this process, then our net efficiency will be very low. Okay, we will get only about, you can say, maybe 20% or 30% efficiency, or maybe even lower. Okay, but if we can directly go to the chemical to electrical, okay, so basically we are eliminating the this conversion to the mechanical. Okay, we are using the electrochemical reaction, so we can directly convert the chemical energy to the electrical energy. So the efficiency will be more, because basically electrochemical reactions are there. Okay, there is no combustion, because in combustion we know that uh, a large amount of energy is going in the exhaust. Okay, because we cannot get the exact combustion, or we cannot get the, you can say, the exact stoichiometry reactions in the combustion. Okay, so the large amount of energy is going through the exhaust and dissipated through the heat. But in this method, using electrochemical devices, we can convert the chemical energy directly to the electrical energy, and we can get a very high efficiency. You can say in the range of more than 80%. Okay, so basically energy storage devices are fuel and oxidants are stored within the device. So uh, as long as the device is having the fuel and oxidant, so that device can supply the energy. Okay, and what are the energy conversion device? So fuel and oxidant are stored external to the device. So basically in energy conversion device, like, we are converting the energy, so we are storing the fuel and oxidant outside the device. Okay, so that is a, you can say, a drawback of the batteries, because batteries, the the supply from the battery is quite limited. Okay, because we have to store both the fuel and oxidant in the device itself. So you can say we can store up to a particular amount only. Okay, after that, after that amount is depleted, we cannot get the energy. But in energy conversion device, we can connect those device completely to the source. Okay, so they can get the supplies of fuel and oxidant as long as we require the electricity. So there is a major difference between the energy storage device and energy conversion device. Now the, what is the cell? So a single electrochemical unit. So basically cell means a single, okay, a single electrochemical unit, such that one anode, one cathode, and the electrolyte. So when we are referring a cell, means it's a single unit. Okay, if we are referring a stack, then we are it's a group of cells which are connected in series, or you can say parallel as our requirement. So battery, or you can say the, a battery is a collection of cells in series or parallel. Basically stack we are using in terminology in fuel cells. Okay, when in fuel cells, if we connect the cells in series or parallel, we say then stack. But here we are saying it's battery. So battery is a collection of cells in series or parallel. Primary cell, a single use power source. and secondary cell can be recharged. So there are two types of cells, basically primary and secondary. So primary, you can say single use power source. So it's a single use and throw. So you are having a particular cell that is having some capacity. So if you use that complete capacity, you cannot draw further power from that particular cell and you have to replace that. But in secondary cell, you can recharge those cells. Okay. So like you,
I have one, sir,
yeah,
Sarmadar.
yeah,
This
please.
one, fuel cell, actually, there's, since fuel cell is a very new concept also,
Right.
fuel cell is considered as a conversion device or a storage device.
Now, fuel cell is not a storage device; it's conversion device. Because
So,
in because in fuel cell, because in fuel cell we are not, the device is not storing anything. Device is just a combination of anode, an electrolyte, and cathode. Your complete fuel and oxidant are outside. Okay, and you are converting the chemical energy into electrical energy directly. So
the
fuel cell are
you mean,
most fuel cells are most efficient device for energy conversion.
but the thing is that both the units like this, the cell and the fuel cell, these
Okay.
two are using, uh, one is using both are using the same principles, electrochemical reaction,
Yeah, principle are same.
or
That's
not?
why, yeah. That's why fuel cell is also electrochemical device. Battery is also a electrochemical device. Okay.
Hmm.
So they both are electrochemical devices, but both are different. One is energy storage device and one is energy conversion device.
And one, and the battery has its own resources within the device.
Yeah, battery has its own resources. Yeah, right. Suppose you are having a particular battery, okay, but you will get the electricity as long as that battery is having sufficient chemicals inside that. Okay,
Okay.
but after the depletion of chemicals, after the depletion of chemicals in the battery or fuel or oxidant in the battery, you will not get any output. And another point is that with the time, okay, with the time, as the chemicals are are reducing, the output from the battery is also affecting. The cell voltage will also decrease, power output will also decrease. Okay, but that is not the case with the fuel cell. With the fuel cell, with the constant supply of fuel and oxidant, you can get
Yes.
a constant amount of electricity, a constant voltage, constant current. Okay, so that is the beauty of fuel cell.
Right. Okay.
So in future, uh,
Efficiency wise, which one is better?
actually, if you go like actually both are different. If you are like fuel cell and batteries, both are different actually. Okay, because in battery you are storing the electricity from where? Okay, either you are using the solar energy, so that is a different thing. So
Mm.
like if you actually it depends, you can not, it's not a simple way to calculate compare the efficiency of fuel cell and batteries, because the both are actually totally different. If you compare the efficiency of fuel cell with the engine, then you can compare, because both are energy conversion device. Because
Mm.
here the battery is storage device and that is conversion device. So
Right.
efficiency wise,
So the
yeah, efficiency wise, there will be actually you have to define first the parameters, then only you can compare the efficiency.
okay. Well,
But the
ठीक.
efficiency of fuel cell is very more. If you compare all the parameters, then the result will be that fuel cell is more efficient.
More efficient. Okay.
Yeah, yeah.
Okay. Yeah. Thank you.
Okay. So these are the standard electrochemical series. Okay, so these are the standard electrochemical potential. So they are all in the reduction reactions. Okay, so the main point, you can see the hydrogen, or you can say standard hydrogen electrode, or it is also called SHC. So for this we are considering 0 volt, and based on this we are having voltage for other reactions. Okay, So these are all half cell reactions. They are not complete reactions. Okay. So these are only reduction reactions. You can see the electrons are utilizing. Okay, they are not losing the particular element. Like this hydrogen is getting the electron and converting to the hydrogen. This Pb is getting the electrons and converting to Pb. So all are reduction reactions. Okay. So the basic conclusion from the basics of battery is that batteries have specific parts that can have dramatically opposite functions. Okay. The electrochemical series is the starting point to understand batteries voltage, and the primary and secondary batteries are both commercially used. So we are using both batteries commercially, and electrochemical series is the starting point. This starting point to understand the battery voltage. Okay, it's we can have different elements and different reactions. So based on that, we can find the complete voltage from that particular battery using these standard electrode potentials. For more detail, you can refer the class video. Now come to the cell characteristics. Okay, so what is the capacity? So the capacity of a cell is the total charge in cell. Total charge in cell, or you can say coulombs or ampere hour. So the unit is coulombs or ampere hour. So it's the total charge in cell. Okay. So voltage is V, current is I. So power in watts will be V into I. It's a very popular formula. I think we are using from class 8. So power is V into I, voltage into current. Time is T. So if you want to find out the energy, then just multiply with the time, because watts is joule per second. So this is the rate of, you can say, the energy, rate of doing work. So if you want to find out the energy, then multiply it with time. Okay, so this will cut, we will get the joules. Joules is energy, or Newton into meter. So basically Newton into meter is the mechanical work. Okay, so similarly this is the work. Okay, so energy, power into time, or joule into, or watt hour. Okay, watt hour. So for example, in our house, our electrical units are coming in 1 kWh. Okay, our units are in kWh. Anyone know about kWh? What is the meaning of this 1 kWh? Anyone who are available? If you want to share your thoughts about kilowatt hour, like suppose if we are using a
One,
particular light bulb that is having the rating capacity, like rated power is 100 watt, then what is the meaning of this 1 kWh?
1 kWh is 1 unit, is 1
What,
kilowatt hour.
1 unit? Okay, so what is the significance? Suppose I am having a house
1000
with
watt consumed in 1 hour.
1000 watts
Consumed in 1 hour.
consumed in 1 hour. So you are saying 1 kWh, 1000 watts consumed in 1 hour.
One,
So suppose I
one.
am having a 100 watt bulb in my house, then in how much time my electric meter will show 1 unit?
10 hours.
Yeah, right. So basically, we are calculating that in 1 hour we are getting 1000 watts of work, and we are considering 1 kWh. Okay. So based on the electrical rating of the equipments, okay. Suppose in house we are having refrigerators and lights, fans, cooler, AC. So they are having all their capacity or rated ratings. So based on that, our electrical meter is taking the readings. Okay. So now let's come to the battery testing. So for battery testing, we can test the batteries Okay, so we have in our previous slides we have seen that for battery very important parameters are voltage and ampere. Okay, so here you can see that we can connect the battery with ampere meter or voltmeter. Okay, so we can connect a load, we can see the voltage, and through the ampere meter we can see the flow current or amperes from the battery. So basically using voltmeter and ampere meters we can test our battery. So for research purpose, there are very delicate machines. They are intensively developed for the battery testing, because electrochemical device we are having huge materials. Okay, so scientists are working towards developing new electrochemical reactions, because they are developing some chemistry. They are changing the atoms, and they are doing some different reactions. They are changing the electrolyte materials, and they are tweaking the electrochemistry, basically you can say. So the main objective of the complete research is to increase the efficiency and to decrease the environmental hazards. Okay, and to simplify the process. So that is our main objective of the research. So using voltmeter and ampere meter, we can test the battery, like what is the uh, what is the charging or what is the discharge cycle, what is the continuous voltage it can produce, what is the maximum current, minimum current, what is the open circuit voltage. So like that we can completely test the batteries. Now come to the C rate. So C rate is very important actually. So the C rate, the C rate is the rate at which the battery is discharged or charged. So the C rate is the rate at which the battery is discharged or charged relative to its capacity. So that is called the C rate. So if you are having one C rate, so it means that it will discharge or charge in 1 hour. If you are having two C rate, then it will charge or discharge in 1/2 hour. So basically time is, you can say, 1 by C. Okay. If you want to find out the time required for charging or discharging, just reciprocal the given C rate. Like 5C, so it will take 1/5 hour, or you can say 12 minutes. Similarly, 0.1 C rate, it means 1/0.1 hour, you can say 10 hours. Okay, so this is a basic formula. Time will be 1/C. It is useful, remember it. So C rate is a rate at which the battery is discharged or charged relative to its capacity. So the C rate is unit. C rate is the unit battery experts use to measure the speed at which a battery is fully charged or discharged. For example, charging at C rate of 1C means that the battery is charged from 0 to 100% in 1 hour. A C rate higher than 1C means a faster charge. For example, 3C rate is 3 times faster, so a full charge in 20 minutes. Okay. Likewise, a lower C rate means lower charge. So C by 5 means 0.2C would be 5 times slower than 1C, amounting to 5-hour charge. Okay. So these are the curve, like discharge and charge curve. So in this first curve, green curve, the battery is discharging with the time. Okay, as the battery is discharging, you can see the voltage is also decreasing. Okay, the voltage is decreasing with the time. Similarly, in the charging, you can see the voltage is increasing with the charging. So in both curves can be overlapped in one curve. So this is discharge, and this one is charge. Now in this curve we can see the effect of C rate. Okay, so more the C rate, you can see it's getting very fast discharging. Okay, so 5C, or you can say fast discharging or fast charging. So its capacity is, you can say, as compared to 5C, 2C, C and C by 2. So 5C can hold less capacity as compared to 2C, as compared to C, and as compared to C by 2. So if you are having C by 2, we can get more stable output of voltage as compared to the 5C and other C's. Okay, so at lower the C rate means the, you can say, the more stable voltage we are getting, more stable, you can say, the more stable performance from the battery we are getting, because you can see this straight line. Okay, so it's a quite very stable performance. Initially, at the starting and the ending, there are some losses we will cover, but in between there's a long straight line, so we are getting stable performance. So these are a basic, a simple polarization curve in which three losses are there basically: activation loss, ohmic loss, and mass transport loss. Okay, so these three losses are very important loss. They are both for batteries and for fuel cells also. So actually these are losses for electrochemical reactions. Okay, so whenever we are having electrochemical reactions, then we are having these losses. So activation loss, you can say, activation means we whenever electrochemical reaction is happening, there is some energy barrier. Okay, so for that electrochemical reactions to happen, uh, there should be, the reaction should cross a one particular energy barrier, because after that, after crossing that barrier only, the electrochemical reactions can happen. So suppose your electrochemical reactions can generate, like, suppose 1.5 voltage, but zero point 0.2 voltage of zero point 0.2 voltage is going to lose, or you can say some amount of current, or some amount of energy, that will be quite convenient to say. Some energy is going to fulfill that activation barrier, and after that only we can get the complete energy from that particular reactions. So some energy, you are say, some losses will be there, so that some energy is going for that particular activation barrier. After that, our complete reaction will happen and we will get the energy. So that will be the activation loss. Ohmic loss. Ohmic loss, suppose we are having some devices, and so they are having their resistance. Okay, having anode, cathode, electrolyte. So all are having their material properties and electrical, in the electrical circuit, in external electric circuit also. The wires are also there, fittings, and various things. So they are having some resistance to flow of the electron. So there will be ohmic loss, and the mass transport loss, as we increase the current density, like if we are withdrawing more and more power from the cell, so more and more electrons or ions will be there, so there will be mass transport losses. So for further detail, in deep detail, you can refer a reference book for these. Okay, but these are very important actually. For to understand the electrochemical reactions, this polarization curve is very important. So you can see the pattern of this polarization curve. For the initial part, you can say from up to here, there's activation loss. From up to here, there is ohmic loss, and after that there is mass transport loss. Okay. So basically, the measure, you can see the measure losses is in. So ohmic loss is quite long region. So I think we will operate in this region only, because if we go into this region at very high current density, then there is a huge drop in voltage. So that will be not convenient to us. So our aim is to operate basically at a condition where we are getting a good amount of voltage and good amount of current. Okay. So the X part is showing the current density is basically ampere per centimeter square. So suppose we are having some area, and from per centimeter square area, how much current we are getting, that is current density. In the voltage, how much voltage we are getting, that is voltage. So we can also draw a power curve, okay, with the power with the current density. So the voltage is decreasing if we are increasing the current density. Voltage is, you can say, decreasing if you are increasing the current density, and power is increasing. You can see now power is increasing with the current density. So at a particular point, you can say at this point, when both are crossing, so I think this point will be the point of operation. Our aim is to operate the cell at this point. So at this point, we are having voltage and power. Okay, both are very good actually. If we further increase, then power is increasing, but the voltage is decreasing. Okay, but if you require both voltage and power, then we will operate at this point. If you want more power and less voltage, then we can go further. But we cannot go beyond. Don't want to go beyond this point, because if we move beyond this point, then there will be huge losses due to the mass transportation losses. Okay, so this dotted curve is showing the power, and this curve is showing the polarization curve, okay, which is showing the drop of voltage with current density. So if suppose there are two cells, cell A and cell B, so these are the polarization curve. So our aim is to select the cell which is having a good polarization curve. Okay, so from these two graphs we can see the cell A is having more stable and the curve with high voltage as compared to the cell B. So whenever if we are having two cells and we have to decide a one cell for our particular equipment, so we will see the polarization curve for both cells, and based on that we will select the cell. So in this case, in this particular case, we will go for cell A, because cell A is having more stable and good polarization curve as compared to the cell B. So the conclusion from these slides is that a C rate indicates the rate at which the battery is being charged or discharged relative to its capacity. Okay. And the charge discharge curves typically show steady performance of the batteries, excepting close to the fully charged and full discharge conditions. Okay. The polarization curve enables comparison between batteries from the perspective of power delivery. Okay. So that it's enabling us to comparison between the batteries from the perspective of power delivery. Now come to the different types of battery structures. Okay, so as in our daily life we have seen multiple batteries. I think every one of you have seen the cylindrical batteries, cylindrical cells. You can say that the AA or AAA batteries that we are using in our our watches, okay, in our trimmers, okay, in our torch, okay. So these are basic cylindrical batteries in the shape of like this. So in the button cell, mostly these are used in the, you can say, the in calculators, okay, in wristwatches. It's just a simple cylindrical cell. Prismatic cell, so it can be actually, it can be in any shape. You can say in basically a rectangular, but like in our mobile phones, you can see the prismatic cells of our mobile phones, laptops, and all. The pouch cell, so basically in this, we can have the battery is similar to a pouch. Okay, so this is not a, you can say it's not in a solid form, so it is in a pouch. So chemicals are filled in those pouches and they are electrochemically reacting and generating the electricity. So for very lightweight application, we are using the pouch cells. So this is the button cell. So we are having anode, we are having cathode, we are having a separator. It also act as an electrolyte. Okay, so this is the complete setup of button cell. So this separator is basically separating the anode and cathode. Okay, and also working as electrolyte. So actually it's eliminating the direct connection between the anode and cathode, and it is also ensuring that no electron will pass through direct anode to cathode. Only the electron will pass through the external circuit. Okay, only ions will pass through the inlet to cathode. So the cylindrical cell, here also we are having anode, cathode and separator, anode, cathode and separators. This is a basic structure. This prismatic cell, so here this you can see the cross section. So we are also having anode, cathode and separator. It's very popular in cell phones. Pouch cell, so you can see the two are terminals and there is a like pouch like structure. So in which chemicals are filled, they can react and generate the power. So these are basically four battery structures we have covered: cylindrical, button, prismatic and pouch. Now come to the rechargeable batteries. So these batteries, as we have covered initially, primary and secondary batteries. So primary batteries they are not rechargeable. Once we have used, we have to replace them. But rechargeable batteries can be recharged. Okay, once we have used those batteries, so we can again put some electricity to that battery and we can recharge them. So lead acid batteries, first example. So it is having a very high current density. It's a high current density. So one side is lead, other is lead oxide, and electrolyzes sulfuric hydrogen sulfate, H2SO4, sulfuric acid. So you can see the reactions. So PbS plus H2SO4 converting to PbSO4 plus 2H plus 2 electron. So these two electrons will go through the external circuit and this 2H plus will go through electrolyte. So at electrolyte it will go and it will react with this PbO2. 2H plus 2 electron is coming through the external circuit. So the cathode reaction will be, you can see, it will be PbSO4 plus 2H2O. So these are the reactions. So in this we can see the electrons flow is there, these two electrons, okay, through the external circuit, and the ions flow is from electrolyte. Okay. In this way the electrochemical reactions are happening and we are getting the current. So this is lead acid battery, and the good point of this is its high current density, but also we know that lead is very toxic. So it is toxic in nature. So that's why we don't want to use this type of batteries, because once the battery once the battery life is over, then it's very difficult to manage the battery waste. Okay, because it's very toxic. So this is a very major drawback of this type of batteries, lead acid batteries. But the good point is that it's having high current density. So nickel cadmium batteries, NiCad, these are also rechargeable. And the good point is that they are high cycle life. Okay, they are having a very good cycle life, much more than nickel metal hydride batteries, and more reliable. They are more reliable for cycle life. these are having some bad advantages also. You can say the disadvantages or drawbacks, like lower capacity, the nickel metal hydride. They are also toxic because cadmium is very toxic. So also toxic, and memory effect. So these are having memory effect. Suppose if someone is short cycling their batteries, you can say like someone if is charging the battery up to 60 to 70% daily. Okay. So after some time, this battery's capacity will reduce to 60-70% only. They can charge up to 100%, but their material will like think that we have to charge only up to 60 to 70%. So in that sense, we say that these are having memory effect. Okay. So the memory effect is also there for this type of battery. That is not good actually, because if we are not using the battery properly, so we are not able to use the complete capacity of that battery. Okay. That's why uh, it's not good to use. And these are the electrochemical reactions for nickel cadmium batteries. Okay. Again, you can see the electrons are moving through external circuit, and ions are also exchanging through the electrolyte. Sorry. Now the nickel metal hydride batteries, NIMH. So they are also rechargeable. So the advantages of this nickel metal hydride batteries are non-toxic. They can replace alkaline and nickel cadmium. There is no memory effect, so we can use the maximum capacity. These are having high capacity as compared to other batteries. Good energy density approach, that is compared of lithium-ion batteries. So as compared to the available batteries in the market, so lithium-ion is having very good energy density. So nickel metal hydride batteries are comparable energy density to the lithium-ion batteries. Okay, they are non-toxic, replaceable, so they are having a good advantage. They are having no memory effect. That is also a very good advantage. So we can use the maximum capacity. The disadvantage is that it can self-discharge. So it can, if you are not using the battery, yet it can self-discharge, because the chemical reactions are like that, they automatically happening. So metal hydride is reacting with OH minus and converting it into metal, H2 plus electron. H2 electron again reacting with the nickel oxide and OH ion, converting NiOH2 and releasing OH minus ion. So again OH minus is traveling towards the metal hydride, and this reaction is happening. They are coming this side. So if we are considering only one reaction, that is half cell reaction, we are considering both, then these are full cell reactions. Okay. So the reaction one is it oxidation or reduction?
Oxidation, losing
Yeah,
electron.
yeah. The first is oxidation, and lower one is the reduction.
Please repeat the concept of full and half, this half cells.
Because this reaction is happening at anode side, and this is happening at cathode side. Okay, and we know that anode and cathode both are separated using an separator, or you can say the electrolyte. Okay, so there is no direct contact between the anode and cathode. Okay, so if you are considering the anode side reactions only, then that is half cell reaction, or you can say anode side reaction. Okay, so this reaction is, and if you are considering cathode side reaction, so that is this side reaction. Okay, so the half cell reaction for anode side is reaction number 1. Half cell reaction of cathode side is reaction number 2. If you are writing the complete reaction, then what will you do? The complete reaction for this cell will be, because these both are half cell reactions, okay, they are not complete reactions. Let me write the complete reaction now. Do the just little bit of addition and subtraction. So add both sides, so it will be MH plus Ni O OH, okay, will convert to M plus Ni OH2. So this is the complete reaction for this nickel metal hydride. This is complete cell reaction. So these two half cell reactions are there. So basically half cell reactions are showing us the at which what is at where oxidation and about the reduction. Okay, this is the complete reaction. These are half cell reactions.
Similar thing happens in lead acid batteries also.
Yeah, similar, same. Okay.
Yeah, right.
Okay. Okay. Now the lithium-ion batteries. So lithium-ion batteries are also rechargeable. So the advantage of this, it's lighter than nickel metal hydride and better energy density. So it's very lightweight. So today we know that weight is a very critical factor. Okay, because if you are using the batteries, okay, then weight is a very important factor. Because if the more weight is there, means we need more power for, you can say, the transportation. If you are using like batteries in your devices, then today we are focusing on lighter devices. Like we are reducing the weight of laptops, we are reducing the weight of mobiles and every gadgets. So our aim is to reduce the weight so that we can easily handle, we can carry those in pockets, our small bags. Okay, so weight is a very important factor. So lithium-ion battery is lighter than nickel metal hydride batteries, and also they are having better energy density. So energy density, you mean to say that more energy per kg, or you can say per liter. Okay, so there is energy density, so it's having better energy density. Suppose if the nickel metal hydride is having like they can, you can say, the like suppose small battery can store up to like 20 joules, just for example 20 joules per gram, then maybe this can store 60 joules per gram. Okay, so this is the energy density. So this is like thrice the capacity of this. Okay, so disadvantage is that self discharge. So these are self discharge is there with time. So these are again reactions Li C6 plus Li plus electron. Then these are again taking part in this half cell reactions and converting into LiCO2. So the complete reaction will be LiC6 plus CO O2 will be LiCO2. Okay. Now the alkaline. So these are non-rechargeable batteries. So you cannot recharge these batteries, and don't try to recharge any non-rechargeable batteries, because that can, because the material inside the battery does not support the reverse reaction, or you can say you cannot reverse the reaction by supplying the electricity. You mean to say charge, you can charge the battery again. So in non-rechargeable batteries, if you supply the electricity or if you try to charge, then maybe some other reaction can happen, or that can explode the battery, or maybe some accident can happen. So don't try to recharge a non-rechargeable batteries. Okay. So alkaline batteries are non-rechargeable batteries. The advantage is that they're inexpensive, So the rate is quite low due to the easily availability of materials and alkaline solutions. Okay, like OH minus ions, you can say you can easily generate these reactions. As compared to other batteries, lithium like quite expensive rare earth metal. So like those, it's very easy. So that's why it's inexpensive. But the drawback is that may not deliver as much current. So current density is very low. The reactions is zinc reacting with hydroxyl ion, converting to zinc oxide with H2O plus 2 electron. Then MnO2 is reacting with the H2O plus 2 electron, converting into Mn2O3 and 2OH minus ion. So these are the reactions. Again, carbon zinc battery, non rechargeable, very expensive. It's very expensive. It's low expensive. It's more cheap than the previous alkaline batteries. The drawback is that these batteries are having very low energy density. So the energy density is very low. So we don't want to use these type of batteries. Okay. But due to the cost, some areas are using, I think, these batteries. The reaction is zinc Zn plus 2 plus 2 electron and 2 MnO2 plus 2 NH4Cl plus 2 electron Mn2O3 2 NH3 plus H2O plus 2 Cl minus. These are the reactions. Okay. So here oxidation of zinc is happening. Here you can see the reduction. So the conclusion is that there are a wide range of batteries type. We have covered different batteries. These batteries differ from each other in terms of capacity, environmental friendliness, current densities supported, okay, and the cycle life. So we have seen that the current density is different and different. Like some are toxic and some are non-toxic. Okay, cycle life, some are automatically reducing the battery life and some are retaining the battery, some are having memory effect and all. We have seen these parameters. And third one is careful analysis is needed to match a battery with a specific end use. So whenever we want to decide a battery for a particular application, then we have to carefully analyze our requirement first, and based on our requirement we have to decide the battery. Okay, because every battery is having their own advantage and their own drawbacks. Okay, so we have to consider all those advantages and disadvantages, and we have to also consider our requirements. Based on that, we can only carefully analyze our required battery. Now come to the again lithium-ion batteries, because these are quite very common today. Because in most of the appliances we are using these type of batteries in our mobiles, laptops, in transportation sector. So mostly we are using lithium-ion batteries. So we are using lithium-ion batteries, but this is only lithium batteries. So these are non-rechargeable batteries. Okay. So these are high energy density and lightweight and expensive. Now come to the lithium-ion batteries which are chargeable. So lithium is one of the most electropositive element. So what are the some important characteristics, so you can say the points for lithium? The first one is that lithium is one of the most electropositive elements. It is lightweight, very lightweight, like 0.53 gram per centimeter cube. It's environmentally friendly. It is non-toxic, so we can
Sir, we
handle.
have no sound. We have no sound. Please.
Okay, let me check. Are you having the sound now?
No, no, I am getting your sound. Maybe problem with his side.
Yeah, please check your speaker, because
I am able to hear.
yeah, because other participants are saying that they can hear me. So I think you have to check your speaker. Anyone can please post in the message box. Anyone can post it on the message box. Okay, so let's continue. So lithium is the one of the most electropositive elements, and it's a very lightweight. You can see the weight is 0.53 gram per centimeter cube, and it's very environment friendly, and it's having high energy density also. So we can like with a very less amount of lithium, we are getting more energy. That's why we are using lithium ion batteries, because whenever we are designing any device, like today you can see that every day new models of mobile phones are launching, and they are saying that this is the lightest mobile and this is that and all. And today we also see the laptops, ultrabooks, they are very thin. So it's only possible due to lithium ion batteries. Okay, they are having good battery backups also, and lightweight also. Okay, so the best example for in terms of battery backup, uh, we can consider the Apple products. They are having a very good battery backups. Okay, so and the size is also, you can say, quite small. So the quality of maybe the lithium ion batteries they are using is quite maybe good. Okay, we are not promoting any company, just we are considering an example for our study purpose. So lithium ion batteries is quite very good. So they are lightweight and they are providing a good amount of energy density. So in less area with less weight, we can get more electricity. Okay, now the dendritic growth of lithium or SEI. So these are having porous structure that grows on anode with each recharge cycle. So there's dendritic growth in lithium batteries. So that is a porous structure that grows on anode with each recharge cycle. It can result in internal short circuit. So there is a one phenomena with lithium ion batteries, that a porous structure is grows with every recharge cycle. Let's see what is it. So this is a like uh, lithium ion batteries, like anode and cathode, electrolyte, anode, electrolyte, and cathode. Okay. So after one cycle or after some cycles, you can see the some dendritic growth is happening at the anode side. These after some time you can see it's growing, and you can see there is a contact between the anode and cathode. So as we know, for a fundamental electrochemical reactions, there should be no contact between the anode and cathode, because if there is a contact between the anode and cathode, then what will happen? The electron will not go through the external circuit. They will go through this contact. Okay, so it means that our external circuit will not get any electron, so we will get V equal to 0 voltage, or we will get no current. Okay, so it will short circuit the system, because the electron are directly going through this way. Okay, so this is the dendritic growth of lithium. Now we come to the intercalation. So basically intercalations means that in the host lattice, like carbon based host lattice are there. So we are doping the other material on the vacancies of that host material. Okay, so in this lithium ion batteries, we are doping the lithium in the carbon based host materials, like you can see the Li6. So anode is Li6, so C6, you can see the carbon is 6 times, and we are providing the lithium to the some vacancies in the carbon structure, C6 structure. Okay, graphite structure, you can say graphite. And cathode side is LiMn2O4. Electrolyte is LiPF6, lithium hexafluorophosphate in ethylene carbonate and diethyl carbonate. So here you can see the graphite. Okay, This is the structure of graphite. So this is a unit cell. These are, you can say, the length of A and B. Okay. For more detail regarding this, please refer the class videos. So here you can see we can see the layers of the graphite. Okay. Now this lithium is there, so this lithium can come in these layers. That is called intercalation. Okay. So this is the host, and this is guest. So guest is coming to the host. Okay, at some locations. So this is stage 4. So we are having lithiums, and after that there are 4 layers, and again lithium, then again 1, 2, 3, and 4 layers, then again lithium. This is called stage 4 intercalation. In stage 3 intercalation, there are 3 layers of host, and lithium is there. So in stage 3, more lithium ion is present as compared to stage 4. In stage 2, more lithium ions are present because only two graphite layer is there. Okay. In stage 1, there are more lithium ions. Okay. So this is stage 1, 2, 3, and 4. Now come to the electrolyte stability window. So there should be electrolyte stability window is that if the anode and cathode potentials are between the LUMO and HOMO. Okay. For more detail, please refer the class videos regarding this electrolyte stability window explanation. So the conclusion is that lithium metal based rechargeable batteries can develop internal short circuit with repeated cycling. Because if we are going repeated cycling, then we have seen that dendritic growth is there. So after certain period of time, the dendritic growth from anode side is up to the cathode side, and the electron will not go through the external circuit, and they will go through the dendritic growth, and short circuit will happen. Lithium-ion batteries overcome this issue, and intercalation and host compounds make lithium-ion batteries safe. Okay, and we are doing intercalation. And HOMO and LUMO of electrolyte important in determining electrolyte stability window. Now let's come to the question section. Now we will discuss some questions. Please take 2 to 3 minutes to answer the question. Try to find the answer. Try to recall the class notes, class videos, and our today's PPT. The first question is that a battery is an option A, electrochemical device, B, energy storage device, C, energy conversion device, D is internal combustion device. So take 2-3 minutes and answer.
Option 1 and 2. Think so.
Option 1 and 2, electrochemical device and energy storage devices. Okay, just wait 1 more minute if anybody else want to answer.
Third also, first, second, third. Conversion also.
Energy conversion device. Okay, we'll see. Okay, the first option is that the question is that battery is N. So as we have covered, battery is a electrochemical device because electrochemical reactions are happening. So from the options we can see the option 1 is correct because it's a electrochemical device. Now come to the fourth option, internal combustion device. So is it internal combustion device? So no, because there is no combustion. So option D will be wrong. Now come to the option B and C. So B is energy storage device. So yes, because in battery we can store some chemicals and that chemical can deliver energy. So it's energy storage device also. So B seems also correct. Now C, energy conversion device. So this is quite complicated because like conversion. So energy conversion device are those devices which are converting the energy directly. Okay. Battery is also converting the energy. You can say it that we are storing the chemical in the battery and we are getting the electrical energy. So in that sense, it's converting, but it's not. You can not get the electricity as long as you are, because there is no continuous supply of electricity from the battery. Okay, because there is no continuous supply of the fuel and oxidant. So basically you are having some portion of fuel and oxidant, you are putting those, you can say, in the battery, and from that you are putting some chemicals in the battery, and from that you are getting the electricity. So basically you are not having continuous supply, so we cannot put the battery in electro energy conversion device. Okay, so fuel cell will come in energy conversion device, battery will come in energy storage device. Okay, because it's converting, but basically just we are storing the chemical energy. Okay, conversion when we are continuously having conversion, like IC engine you can say. Okay, there is no storage, only conversion is happening. So option C is also wrong. So correct answers are A and B. Question number 2. Most metals can undergo oxidation. True or false?
True.
Okay. Let's wait
True.
1 or 2 minutes. Okay. So what is the oxidation? Anyone wants to tell? So basically oxidation means loss of electrons. Okay. Yeah. So most metals can undergo oxidation. Okay. So metals are having lots of electrons. Okay. So they try to attain the stable conditions. So they will try to lose the electrons. In that way, most metals can undergo oxidation. So this statement is also true. Question number 3. When electrons in a battery move through the internal circuit in an unhindered manner, then the Open circuit voltage is increased, external short circuit is observed, internal short circuit is observed, zero voltage in the battery is observed. Read the question carefully and also option carefully. Take 2-3 minutes.
Third and fourth, I think so.
Third and fourth, internal short circuit is observed, zero voltage in the battery is observed. Okay, let's see. The answers are internal short circuit is observed and zero voltage in the battery is observed, because as we know that if suppose this is your cell, okay, this is anode, cathode and electrolyte. Okay, so there is external circuit. If electron is, there is no circuit externally. Okay, if electrons are going through this way, okay, it means there is direct contact of anode and cathode. There is direct link between both, but basically there should be no link. There should be no direct contact between the anode and cathode. So what will happen? There is internally short circuit is there. So from this short circuit, the electrons will flow through this way. So electrons are not flowing through the external circuit. So it means that there will be zero voltage in voltmeter. Okay, we will get zero voltage in the output. So option C and D are correct. Open circuit voltage is increased. It is wrong, because there will be no voltage from the circuit, because circuit is complete but there is short circuit between the anode and cathode. Okay, the external short circuit is observed because there is no external short circuit, because internally anode and cathode are in contact. Option A is wrong, B is wrong. Question number 4, what happens when electrons in a battery move through the external circuit that has a finite resistance? Battery voltage decrease, external short circuit occurs, internal short circuit occurs, battery voltage increase. Please take 2 minutes to answer.
Only option A.
Battery voltage decrease. Okay, let's see. Just, wait a little bit more. So what happens when electrons in a battery move through the external circuit that has a finite resistance? So there is there we having like complete statement which is saying that the circuit is complete and it has a finite resistance. Okay, so finite resistance, it means that it will that this resistance will you can say the resist the flow of electrons. Okay, so basically resist the flow of current, so it means that the voltage will decrease. Okay, so the battery voltage will decrease is the correct answer. And why the other options are incorrect? Because external short circuit occurs. So due to the resistance, there is no short circuit. Short circuit only occurs when there is a direct contact of anode and cathode. Option B is wrong. Option C is also wrong because there is no internally contact of anode and cathode. Okay, because there is a separator and electrolyte. Okay, battery voltage increase, no, because if there is a finite resistance, then battery voltage cannot increase, it will decrease with time. Option A is correct. Question number 5, match the following. We are having two columns. Column 1 is having properties like thermodynamics, kinetics, electrode, electrolyte. Option column 2 is having some other like good ionic conductivity. For batteries, you have to see these column 1 and 2 from the perspective, battery perspective, and you have to match these columns. Okay, so take 2-3 minutes and let me know the answer. Try to think about the electrode, like what should be the properties for electrode, what should be the properties for electrolyte. You can like consider the, if we are designing any battery, then what should be the ideal conditions. Based on that, we have to select the electrode and electrolyte. So option C and D you can easily match.
Is there any chance that in the match the following also there is multiple select type answers are there?
Yeah, because if it is not mentioned, if it is not mentioned in the question, then it can be. And I think in our previous week, I don't know exact number, we have two answers for best the followings. Yeah, we have.
So like if you select one which is correct and if you select another option which is wrong, so your at least 50% is saved, no?
Yeah, I think partial marking is there. Yeah.
No, but I think they are not giving partial marking. I have seen the last result.
Okay, they're not giving. Okay, maybe, yeah. Please check the policy with the NPTEL team. Actually, maybe there are some changes. So I'm not aware of those changes. So you can contact the NPTEL team regarding this doubt.
If
They
you
will
if
sort
you
it.
if you are selecting any of the option wrong, and
Okay.
even though you select one option right, and
Okay.
if you make one option wrong means your whole answer is zero. I mean,
Yeah,
your
maybe.
point is zero.
Yeah, maybe that's the case. Yeah, I'm not aware of that. Yeah.
It is like a IES paper. IES.
Right. Because yeah, this NPTEL is from IIT, so yeah, level is quite good. So try to answer. Anyone?
One, only two. Second option.
Option number second, A5, B2, C4, D1. Okay, let's see. So you are saying that A5, so thermodynamics for 5 ability of the reactions to happen. So right. So thermodynamics of the cell, basically defining how what is the ability of reactions to happen. So yeah, it's correct. Kinetics is how fast the reaction, because kinetics, if we are talking about the kinetics, means we are talking about the rate of reaction. So how fast the reaction is occurring. Electrode, so electrode should be good electronic conductivity. Yeah, because the electrodes like anode and cathode, so the uh, electrons are flowing through the anode to the cathode. Okay, so electrodes should have good electronic conductivity. So there should be a very easy path for the electron flow. So correct, electrodes should have good electronic conductivity. Electrolyte, so option 1, good ionic conductivity, because we know that electrolyte should be have good ionic conductivity, because there should be no flow of electron from the electrolyte, only ions should flow from the electrolyte. So electrolyte should have good ionic conductivity and zero electronic conductivity. So yeah, it seems option B is correct. Option B is correct. Let's check if any other option is also correct, because A5, yeah, in C also A5, B2 and C3. So C3, C electrode 3, poor ionic conductivity. Poor ionic conductivity. Yeah, it can be. And what about the D electrolyte? D4, ability of the reactions to happen. So D is wrong actually. So electrolyte is for the good ionic conductivity, not for ability of the reactions to happen. Because ability is defined by the kinetics, uh, or sorry, thermodynamics. Okay. So A is for 5. Option C, D, and A are wrong. Correct option is option A5, B2, C4, and D1. What is the question? Oh, okay, question number 6. Question number 6 is corrosion reaction are and battery reactions are different from each because activation barrier needs to be. Okay. I think today we have not covered this corrosion, but yeah, you all have taken the classes, so I think you can answer. So corrosion reactions and battery reactions are different from each other because activation barrier needs to be. Let's take 2-3 minutes.
Listen, barrier to be increased in corrosion reaction, na? To avoid corrosion.
Yeah. Okay. Yeah, just apply your basic fundamentals, like we should avoid or we should promote corrosion. So we should avoid the corrosion and we should promote the battery reactions. So in that way you can think. So anyone else want to answer? So what are the correct options? Anyone? Today I'm getting the answers from only one participant. What about other two participants? The question is, corrosion reactions and battery reactions are different from each other because activation barrier needs to be. So activation barrier, I have told you that activation barrier is the barrier that is there for reactions. So first of all, we have to uh, overcome the activation barrier. After that only the complete reaction will occur. Okay, so activation barrier we have to cross. So we never want that corrosion should be there. So for corrosion, activation barrier should be high, and we want that battery reactions are happen very easily. So we try to have lower activation barrier. Okay, so the correct option will be corrosion reaction and battery reactions are different from each other because activation barrier needs to be increased in corrosion reaction and decreased in battery reactions. Okay, so two options are correct. First is increase in corrosion reactions and then decreased in battery reactions. Option A and C are correct. Okay. Question number 7. Prismatic cells are better than other types of cells because option A, when arranged in parallel or series, significant extra gap remains between the cells to accommodate swelling. They can be arranged in parallels or series without gaps. They are better suited for use in mobile application due to space requirement. These cells are softer in comparison to all other cells. Take 2-3 minutes.
Option 3 is the only one.
Option
Option 3.
Option 3. These are better suited for use in mobile application due to space constraint. Yeah, it can be. Go through other options also. Maybe more than one options can correct. So what are the benefit of prismatic cells?
The small compact.
Yeah, small, compact, and you can think about some other options also, like you can just take example of your mobile battery. So in mobile battery, how many number of cells are there? Can you see how many numbers of cells are there?
Yeah. There are in series. Yeah.
Yeah. So because there is no gap and they can be
Yeah.
arranged in parallel or series without gaps. Okay. That is also a
Yeah.
quality of this prismatic cell. So the correct answers are they can be arranged in parallel and series without gaps, and these are better suited for use in mobile application due to space constraint. So option B and option C are
C.
correct. Okay. Number 8. Plating stripping mechanism is observed in lithium metal based batteries. Assertion is we have given one statement and we have given assertions like it can lead to the battery explosion due to short circuit, and this mechanism leads to dendrite formation in battery. So it's quite complicated. Think for 2-3 minutes and then try to answer. So think about the lithium based batteries in which we have also talked about dendritic formation. Maybe dendrite formation, maybe that can help you.
Option 1 is correct. Option 2 is also correct.
Assertion 1 is right. Assertion 2 is the right and complements the assertion 1. Okay. Let's wait one more minute if anybody else want to answer.
Option 3 is also right.
If you are
But,
saying option 3 is also right, then how can option 1 correct? How can option 1 be correct? Because if option 3 is right, it means that only option 2 is correct. Sorry, statement 2, assertion 2 is correct. But in option 1, option A, you are saying that assertion 1 is right. So relook your answer.
Option 2 and see, this is quite confusing question.
Yeah.
It is short circuited my brains also.
Just think about dendrite formation and what are the implication if there's dendrite formation. So as we know that if dendrite formation is there, then it means that there will be short circuit. And if we know from basic fundamentals that if there is short circuit, then there is chance of battery explosion. So yeah, statement 1 is correct. It can lead to battery explosion due to short circuit. Okay, and this mechanism leads to dendrite formation in battery. So both are correct. And what is the reason of short circuit? Dendrite formation. So assertion 1 is correct and assertion 2 is right and complements the assertion 1. So correct options are A and B. Okay.
Theoretically, dendrite formation is the thing which is happening.
Yeah, it's plating and stripping because we are recharging the battery. So first it's discharging, then again charging. So in that way, plating stripping mechanism is there. Yeah.
Okay, you can go to the next question, please.
Okay. Question number 9 is at higher C rate space capacity and at lower C rate space capacity of the battery can be extracted. So a good question. Think for 3 to 4 minutes. May it require more time.
Sir, C rate is
Sorry?
C rate is capacity rate.
Yeah, C rate, capacity rate. Yeah. Try to remember the polarization curve. We have seen curve for different C rates, and I have also covered like for particular C rate, um, the curve is having more stable performance.
So an option 2 is correct.
Option 2 is okay. At higher C rate, lower capacity, and lower C rate, higher capacity of the battery can be extracted. Okay, we will check. Wait for 1 or 2 minutes for others to answer.
But sir, capacity is total charge in the cell. No?
Yeah, total charge in the cell, but C rate is also defining the timeline, like how fast or how slow you are using that capacity. Okay, so if you are using high C rate,
Inversely proportional to time.
yeah, and you are using low C rate, so there is a difference in time of that to use that capacity. Okay, so maybe if you are using at different C rate, then there will be different implication also. Try to think in that perspective.
The statement higher capacity of the battery can be extracted
Yeah,
means what?
like suppose your battery can generate 100 ampere hour. Okay, so you are having C rate for that particular, okay, capacity. So based on C rate, the suppose if particular C rate can get up to 95 ampere from that battery, but a particular C rate will give you only 80 ampere hour from that battery, or maybe 85 ampere from that battery, lower capacity. Okay, so in practical application, you will get the lower capacity from a designed value due to the C rate. Let's see the answer. So correct answer is at higher C rate, lower capacity, and at lower C rate, higher capacity of the battery can be extracted, because if the C rate is higher, okay, higher C rate means, what is the mean of higher C rate? Suppose if you are having C rate of 5C, so what is the meaning of that? Anybody?
By fifth of the time it will give the it will be of the capacity.
Okay, so basically only 12 minutes you can say, na? So 12 minutes it's get for charge or discharge. Okay, suppose discharge. So it's like you are withdrawing the current at a very high speed. Okay, and you also putting the current at very high speed. So whenever you are doing this type of so more charge will flow in less time. So more charge will flow means there will be heat generated. So some of the energy will be dissipated in the heat form. Okay. I think you have seen like today we are using fast charger to charge our mobile phones. So try to observe fast chargers like sometimes they get heated because they are supplying the current at very faster rate, faster amperes they are generating as compared to the normal charger. Okay. So you feel slightly hotter. So due to that, some heat, some capacity will be dissipated in the form of heat, so that you will observe, you will get lower capacity. At lower C rate, suppose 0.1 C, it means that you are having 10 hours. Okay, you are having long time. So also you can compare from the pollution curve also. For C rate, the curve is quite long, and for higher C rate, curve is short. Okay, so lower C rate is having a large area of ohmic potential as compared to the higher C rate. Because in higher C rate, you will observe that the mass transportation losses will be quite earlier because there is large mass transportation occurring. Okay, so that will be the reason for the slower capacity. Okay, so the correct answer is that at higher C rate, lower capacity, and lower C rate, higher capacity of the battery can be expected. Okay, clear?
Okay, boss.
Yes,
Okay,
sir.
okay. Question number 10. As the current drawn from a cell is steadily increased, the voltage space take 2-3 minutes.
Keeps decreasing.
Just 1 minute. I'm having actually very important call. Just 1 minute. Yeah, hello. Hello. Am I audible? Hello, hello.
Yeah.
Okay.
Only option 3 is the one.
So as the current drawn from a cell is steadily increased, the voltage keep decreasing. Yeah, because as we are current as we are steadily increasing the current, so the voltage will decrease. If we increase the current density, so it mean that the losses will be more. Initially activation loss, then ohmic loss, then mass transportation loss. So the voltage will keeps decreasing. So the correct answer is C. Now let's come to a quiz.
Quiz,
Number
okay.
one is
So,
yeah, please.
the kinetics just confusing little bit. Thermodynamics is okay. It's just the kinetics. Like the kinetics of
Kinetic.
in this
Yeah. Kin
question, what is happening is the current is drawn more.
So when the current density is increasing. Okay, so how will you increase the current density? Think about that.
I didn't get you, sir. What you're saying?
I'm saying that as the current drawn from a cell is steadily increasing. Okay, so basically current density is increasing. Okay, you are
Okay.
drawing more current from per area. Okay, so basically you are
Yes.
increasing current density from the cell. So if you
Sure.
are in, if you have to increase, if you want to increase the current density, then what else you have to do in a cell? You are, suppose you are having a battery, you are having a electrochemical reaction. Okay, and if you have to increase the current density, so how will you increase the current density? Think about that point.
Mm.
Just just give me slight guess, any guess. Suppose if we
You,
want to increase
you,
the current
you
density, then what we can do?
reduce the resistance to the path.
Yeah, reduce the resistance, but I think resistance, we cannot reduce the resistance because once the battery is made, or you have selected the material, then you cannot change the material, na? Suppose you have already installed the battery, then you have
Mm.
already chosen the material, then you cannot change the material in between. Okay,
Mm.
so resistance will be same. So what else you will do? So how will you increase the
Load.
current? So current is increased by the flow of electrons. So it means that you require more flow of electron. So how the more flow of electron is possible? How can we do that? How can we like arrange the more flow of electron?
You cannot change the electrolyte. I mean,
We cannot change the
every,
electrolyte, but yeah, uh, if we increase the rate of electrochemical reactions, or if we increase the rate, means more chemical is taking part in the reaction. Electrochemical reaction is having at a faster rate. It means that more and more electrons are generating. Okay, more and more electrochemical reactions, more and more chemical is reacting. Okay, so more and more electrons will be generating. So when more and more electrons are generating, more and more ions are liberating, so there will be mass transportation losses. So due to that mass transportation losses, voltage will decrease. Okay,
yes, yes, that
at a
is right.
very,
Yeah.
yeah, at a very high current density. Okay, so like suppose, let me tell you, just you can say, suppose some reactions are happening now. So you can say this is electrolyte. Okay, yeah, this side is anode and cathode. Okay, so you have increased the current density to a very high value. Okay, so more and more chemicals are coming. Okay, so what will happen? They will not react properly, because for electrochemical reactions to happen, they require little bit of time, na? At electrolyte, the electrons are liberating, ions are moving, they are all reactions are happening in very microseconds, but still they require some time. But suppose one element of like lithium is there, that is trying to react electrochemically with the ion. Okay, and about to liberate the electron, but instantly one other atom of lithium is coming and pushing it. Okay, so what will happen? It will not react properly. Okay, so further it will go out, and again this atom is trying to react properly, but again more atoms we are giving, so more ions will be there. So in this way, suppose like a particular interface of, okay, interface of the electrolyte, suppose there are 90 atoms, but maybe only 30, or you can say 40 atoms are only reacting properly. So in that way, there will be more resistance. Okay, so that's why voltage will decrease, because voltage is actually giving the efficiency, na. In electrochemical reactions, how we define the efficiency? We define efficiency in terms of voltage. Okay, voltage and power, na. So you are supplying the more input, you are supplying more fuel, but your fuel is not taking part in the electrochemical reactions, because you are supplying suppose 90 lithium atoms, but only 30 lithium atoms are properly taking part in the electrochemical reaction. 60 lithium atoms are not taking part in the electrochemical reactions. Okay, so it means that you have supplied 90 atoms, only 30 atoms taking part, 60 atoms are not taking part, so it means 30% efficiency is only there. So 100 is there, if total 100 and 30 is taking part, 70 is not taking part, it means 30% efficiency is there only. So think in that perspective. Okay, so the mass transportation loss is very high, so it will keep decreasing, first due to activation loss, then ohmic loss, okay, and then mass transportation loss. Okay, it is clear.
Yeah. Okay, fine.
So let's quickly solve this quiz. In the standard electrochemical series, the potential corresponding to hydrogen electrode is set to 0 volt arbitrarily. True or false?
True.
Okay. Batteries that have the same voltage use the same reactants internally.
False.
Because the reactants can different. Electrolytes must have good electronic conductivity in order to complete the circuit and enable the battery to function.
False.
Electrolytes should have good ionic conductivity. Okay. So charging at 6 C rate means a fully discharged battery will be charged in just calculate.
12 minutes.
Sorry,
10 minutes.
10 minutes. Okay. So battery help in moderating the difference between demand and supply across the day by storing and releasing energy as required. True or false?
True.
So the correct answers are, first one is true. Yeah, because we set the hydrogen electrode as 0 and as compare all the other with the hydrogen electrode. Okay. Batteries that have the same voltage use the same reactants internally. No, because voltage can be same. Okay, but the reactants can be different. Electrolytes must have good electronic. No, electrolytes should have good ionic, and electrodes should have good electronic conductivity. Charging 6 C rate means reciprocal of 1 by 6 in so 1 by 6 R, or multiply with 60. So 60 upon 6, you can say 60 upon 6 minute, or 1 by 6 hour, it means 10 minute, because T is equals to 1 by C. Batteries help in moderating the difference between demand and supply across the day by storing the energy released as required. Yeah, true. Okay, I think it's good for today. So thank you everyone for joining this session. Any doubt?
Sarmadar, yeah,
Yeah.
in the final exams, like
Okay.
because there is quiz and there is assignment, and the type of examination is going to be like MCQ, multiple select options, or like written. How is it?
Actually, I'm not aware of the examination pattern, so I suggest you please contact NPTEL team. Yeah. Actually, I'm not aware of. Yeah. Maybe you have received the guidelines on email also regarding the examination. So please go through the guidelines carefully.
Okay,
I
I will
think
check that out.
all questions will be answered. Yeah.
Okay, sir. Okay, thank you so much.
Okay. Okay. Thank you everyone for joining this session.
Thank you,
We
sir.
will. Yeah. This PPT and the recording of this class will be shared with you from the NPTEL team. And we are having another session on next Monday, 6 to 8. I hope you all will join. Okay. Thank you everyone. I'm ending this meeting. Thank you.
Thank you. Thank you.
Thank you.